Imagine a world where lava lakes bubble like boiling water, where volcanoes erupt with such fury they can be seen from Earth, and where the surface is a hellscape of fire and molten rock. This isn't some distant dystopian future. It's happening right now, on Jupiter's moon, Io. This tiny world is the most volcanically active body in our solar system, a place where the very ground is a shifting, fiery maelstrom. In this video, we're diving into the inferno, exploring the mind-blowing scale of Io's volcanism and uncovering the secrets of this fiery moon. Strap in, because we're about to get up close and personal with one of the most dangerous places in our cosmic neighborhood, the fiery heart of the solar system. Beneath the icy crust of Jupiter's moon Io, a tumultuous dance of tidal forces and intense heat brews, making it the most volcanically active body in our solar system. This small moon, slightly larger than Earth's moon, is a fiery heart, a celestial forge where lava lakes churn and volcanic plumes spew sulfur and silicate particles hundreds of kilometers into space. The scale of volcanism on Io is staggering, with over 400 active volcanoes dotting its surface. These eruptions are not mere trickles of molten rock. They are colossal events that can reshape the moon's landscape in a matter of hours. The lava flows can stretch for hundreds of kilometers, and the volcanic plumes can reach altitudes where they are shaped by Io's interaction with Jupiter's magnetic field. The heat driving this volcanic frenzy comes from a process called tidal flexing. As Io orbits Jupiter, the planet's immense gravity squeezes and stretches the moon, generating friction and heat deep within its interior. This heat keeps Io's interior molten, providing a constant supply of magma for its volcanoes. The result is a surface that is constantly being renewed, with new lava flows burying older terrain. The volcanic activity is so intense that Io's surface is the youngest in the solar system, with an average age of only a few 100,000 years. This is a stark contrast to other moons and planets, where surfaces can be billions of years old. The danger posed by Io's volcanic activity is not just a theoretical concern. The moon's surface is a harsh, alien landscape, with temperatures that can swing from -143 degrees Celsius -225 degrees Fahrenheit in the shadows to over 600 degrees C, 900 degree F, near active lava flows. The volcanic plumes can create a temporary atmosphere around Io, filled with sulfur dioxide and other chemicals. This atmosphere is so toxic that it would be lethal to any life as we know it. The radiation environment around Io is also extreme, with high-energy particles from Jupiter's magnetic field bombarding the moon's surface. This makes Io a hostile place, even by the standards of the outer solar system. Despite the danger, Io's volcanic activity offers scientists a unique opportunity to study planetary processes in action. The moon's volcanoes provide a window into the interior of a planetary body, allowing researchers to study the composition and behavior of magma in an environment very different from Earth. The data collected from Io's volcanoes can help us understand the role of tidal forces in shaping planetary bodies and the processes that drive volcanic activity. Moreover, studying Io's volcanoes can provide insights into the early history of the solar system, when similar processes may have been more common. In this sense, Io is not just a fiery heart. It is a beacon of knowledge, illuminating the complex and dynamic processes that shape our solar system. A world of eternal fire. Beneath the icy crust of Europa and the barren landscapes of Ganymede and Callisto, Jupiter's moon Io stands as a fiery testament to the raw power of the solar system. It is a world where the ground never cools, where the very surface is a mosaic of molten rock and ash. Io's volcanism is not a fleeting phenomenon, but a perpetual inferno, driven by the relentless tidal forces exerted by Jupiter and its other moons. This constant squeezing and stretching generates immense heat, enough to keep Io's interior in a state of perpetual turmoil. The result is a landscape pockmarked with volcanoes, some of which are among the most powerful in the solar system. The scale of Io's volcanic activity is staggering. Its surface is dotted with over 400 active volcanoes, each a potential source of devastation. These volcanoes do not merely simmer. They erupt with a fury that can reshape the moon's surface in an instant. lava fountains soar hundreds of kilometers into the thin, sulfur-rich atmosphere, painting the sky with hues of orange and red. The lava itself is not the gentle, slow-moving variety found on Earth. Instead, it is a violent, fast-flowing river of molten rock that can travel great distances before cooling. The largest eruptions can send plumes of debris high above the moon's surface, creating spectacular displays that can be seen from distant spacecraft. The danger posed by Io's volcanic activity is not just a theoretical concern. The moon's surface is a battleground of fire and ice, where the constant eruptions create a hostile environment. The lava flows are not isolated events, but a continuous process, with new eruptions often overlapping old ones. This relentless activity means that Io's surface is in a state of constant flux, with new landforms being created and old ones destroyed. The thin atmosphere, composed primarily of sulfur dioxide, is a byproduct of this volcanic activity. It is a toxic brew that would be deadly to any life as we know it. Despite the harsh conditions, Io's volcanic activity provides a unique opportunity for scientists to study the processes that shape planetary bodies. The data collected from Io's eruptions offers insights into the workings of not just this moon, but also the broader solar system. It is a world of eternal fire, a testament to the raw power of nature, and a reminder of the dynamic and ever-changing nature of the cosmos. Jupiter's volcanic moon. Beneath the vast, swirling clouds of Jupiter, a fiery drama unfolds on the surface of its moon, Io. This celestial body is a volcanic powerhouse, a place where the ground is constantly torn apart by eruptions. Io's volcanism is not a gentle, Earth-like affair, but a relentless, planet-wide conflagration. It's a world where lava fountains shoot up hundreds of kilometers, and rivers of molten rock carve deep channels into the surface. The scale is staggering, with over 400 active volcanoes dotting the landscape, making Io the most volcanically active body in the solar system. The heat driving this fiery spectacle comes from a process called tidal heating. Jupiter's immense gravity tugs and squeezes Io as it orbits, generating friction and intense heat within the moon's interior. This heat builds up until it finds a release, exploding outwards in spectacular volcanic eruptions. The lava on Io is incredibly hot, reaching temperatures of around 700 degrees Celsius. It's a silicate magma, similar to that found on Earth, but the sheer volume and frequency of eruptions are unlike anything seen on our home planet. The surface of Io is a dynamic, ever-changing landscape, with new lava flows constantly burying old ones. The danger posed by Io's volcanism is not just a surface-level concern. The moon's volcanic plumes can reach altitudes of up to 300 kilometers, spewing out a mix of sulfur, sulfur dioxide, and silicate particles. These plumes create a donut-shaped cloud around Io, which is then swept away by Jupiter's magnetic field, creating a vast, hazardous torus of particles. The radiation in this region is intense, posing a significant threat to any spacecraft that might venture too close. Despite the danger, scientists are fascinated by Io, as it provides a unique opportunity to study extreme volcanic processes and the interactions between a moon and its parent planet. Io's volcanic activity has a profound impact on its environment. The constant eruptions paint the surface in vivid hues of red, yellow, and black, creating a stark contrast against the dark, silicate plains. The sulfur and silicate particles ejected by the volcanoes also contribute to a thin, dynamic atmosphere. This atmosphere is constantly being lost to space, only to be replenished by the next volcanic eruption. The interplay between Io's interior, surface, and atmosphere makes it a complex, ever-changing world. It's a place where the raw power of volcanism is on full display, a testament to the incredible forces at work in our solar system. The discovery of Io's inferno. In the vast, icy expanse of the outer solar system, Jupiter's moon Io stands out like a defiant ember, a world awash in volcanic fury. This small, rocky body, slightly larger than Earth's moon, is the most volcanically active place in the solar system. Its surface is a hellscape of molten lava, towering volcanic plumes, and vast lava lakes, a testament to the immense tidal forces exerted by Jupiter's gravity. Io's volcanism is not a gentle, Earth-like affair, but a violent, relentless spectacle of fire and brimstone. The discovery of Io's inferno began in the late 1970s, when the Voyager spacecraft captured images of a world unlike any other. Scientists were astonished to see numerous volcanic features, including active eruptions, vast lava flows, and towering volcanic plumes that spewed sulfur and sulfur dioxide high into the thin atmosphere. The largest of these plumes, from the volcano Pele, reached an altitude of 300 kilometers, dwarfing even the most powerful volcanic eruptions on Earth. This was the first glimpse of Io's true nature, a world in a state of constant, violent upheaval. The scale of Io's volcanism is staggering. The Moon's surface is resurfaced completely every few thousand years, a blink of an eye in geological terms. This is in stark contrast to Earth, where the surface is much older, with some regions dating back billions of years. Io's volcanoes are not merely active, they are explosive and relentless. The lava flows are primarily basaltic, similar to those found on Earth, but the eruptions are more violent due to the interaction of magma with sulfur and other volatile compounds. The result is a landscape that is constantly being torn apart and rebuilt, a dynamic and dangerous world of fire and ice. The danger posed by Io's volcanism is not just a theoretical concern. The intense heat and radiation from the eruptions, combined with the harsh, airless environment, make Io a deadly place. The volcanic plumes, for instance, contain sulfur dioxide, which can form sulfuric acid when it reacts with water. While Io's surface is too hot and dry for liquid water, the Moon's thin atmosphere does contain trace amounts of water vapor, which could potentially react with the sulfur dioxide to form corrosive sulfuric acid. This is just one example of the many hazards that make Io a hostile and unforgiving world. Yet, it is this very hostility that makes Io so fascinating, a natural laboratory for studying the extreme conditions that can exist in the solar system. Voyager's first glimpse. In the frigid expanse of the outer solar system, a fiery spectacle unfolds on the surface of Io, Jupiter's third-largest moon. When the Voyager 1 spacecraft captured its first close-up images of Io in 1979, scientists were astonished. The Moon's surface was a patchwork of yellows, oranges, and reds, a stark contrast to the cold, gray landscapes of other moons. But the most shocking discovery was the presence of active volcanoes, some spewing plumes of gas and ash up to 300 kilometers into the thin, tenuous atmosphere. This was the first time active volcanism had been observed beyond Earth, and the scale was staggering. The images revealed lava flows stretching for hundreds of kilometers, their fiery tendrils carving deep into the Moon's surface. Some of these flows were so vast that they dwarfed even the largest volcanic eruptions on Earth. The heat from these eruptions was intense, with temperatures soaring to over 1,600 degrees Celsius. This inferno was fueled by the immense tidal forces exerted by Jupiter's gravity, which squeezes and stretches Io, generating enough heat to melt rock and create a volcanic landscape unlike any other in the solar system. The danger of this environment is palpable, with the constant threat of eruptions reshaping the surface in a geologic instant. One of the most dramatic features captured by Voyager was the plume from the volcano Pele. This towering column of gas and dust rose high above the surface, creating a dark, umbrella-shaped cloud that spread out over a vast area. The plume was so large that it was visible from a distance of over 400 kilometers. The eruptions on Io are not just powerful, they are relentless. With over 400 active volcanoes, Io is the most volcanically active body in the solar system, a fact that underscores the constant, dynamic nature of its surface. The Moon is a testament to the raw, untamed power of nature, a place where the very ground is in a state of perpetual upheaval. The Voyager images also revealed vast lava lakes, pools of molten rock that glow with an eerie, otherworldly light. These lakes can be hundreds of kilometers across, their surfaces roiling with convection currents as hotter material rises and cooler material sinks. The danger of these lakes is evident in their ability to erupt suddenly, sending fountains of lava high into the air. The scale of these eruptions is hard to comprehend, with some events ejecting material at velocities of up to 1 kilometer per second. This violent activity is a constant reminder of the moon's tumultuous nature, a place where the forces of geology are on full display. Galileo's revelations. In the vast expanse of our solar system, Jupiter's moon Io stands as a fiery testament to the raw power of volcanism. Galileo's revelations about this celestial body have reshaped our understanding of geological activity beyond Earth. Io is a world in constant upheaval, its surface a mosaic of molten lava, towering volcanic plumes, and vast lava lakes. The moon's volcanism is so intense that it constantly resurfaces the entire moon, making it a dynamic and perilous landscape. This relentless activity is driven by the immense tidal forces exerted by Jupiter's gravity, which squeeze and stretch Io, generating heat and fueling its volcanic fury. The scale of volcanism on Io is staggering. Picture a world where volcanoes erupt with such force that they can spew plumes of gas and ash hundreds of kilometers into space. These eruptions are not isolated events, but a continuous spectacle, with over 400 active volcanoes dotting the moon's surface. Some of these volcanoes are so powerful that they can create lava fountains that reach heights of up to a few kilometers. The heat generated by these eruptions is so intense that it can melt rock and create vast lakes of molten lava. These lava lakes, some spanning tens of kilometers, are a stark reminder of the moon's volatile nature. One of the most striking features of Io's volcanism is the constant resurfacing of its terrain. The moon's surface is a patchwork of fresh lava flows, volcanic calderas, and mountainous ridges. This dynamic landscape is a result of the moon's relentless volcanic activity, which constantly reshapes its surface. The constant resurfacing means that Io's surface is relatively young, with some areas being only a few hundred years old. This makes Io a unique laboratory for studying the processes that shape planetary surfaces. The danger posed by Io's volcanism is not to be underestimated. The moon's surface is a hostile environment, with temperatures that can reach hundreds of degrees Celsius. The constant eruptions and volcanic activity make it a perilous place for any potential explorers. Despite these dangers, Io's volcanic activity provides valuable insights into the geological processes that shape our solar system. The data collected by Galileo and other missions have given scientists a deeper understanding of the forces that drive volcanism on Io and other celestial bodies. This knowledge not only expands our understanding of the universe, but also helps us appreciate the dynamic and ever-changing nature of our own planet. A tidal tug-of-war. Beneath the icy crust of Europa, a moon of Jupiter, lies a vast, hidden ocean. But venture further into the gas giant's orbit, and you'll encounter a world that's a stark contrast to Europa's frozen facade. Io, the third largest of Jupiter's moons, is a place where the very ground is a battleground, a stage for a relentless, fiery spectacle. This is a world where volcanoes erupt with such fury that they can be seen from Earth, spewing lava fountains that reach hundreds of kilometers into the sky. The scale of volcanism on Io is staggering, with over 400 active volcanoes dotting its surface, making it the most volcanically active body in the solar system. The reason for Io's fiery nature lies in a celestial tug-of-war, a gravitational dance between Jupiter and its other large moons, Europa, Ganymede, and Callisto. This constant pull and push heats Io's interior through a process called tidal flexing. As Io orbits Jupiter, the planet's immense gravity distorts the moon's shape, squeezing and stretching it like a stress ball. This constant kneading generates tremendous heat, enough to melt rock and create vast reservoirs of magma beneath Io's surface. The result is a moon that's perpetually on the verge of eruption, a volcanic inferno that never sleeps. The danger posed by Io's volcanism is not just a matter of scale, but also of frequency. Unlike Earth, where volcanic activity is sporadic and often predictable, Io's volcanoes erupt constantly, with some entering a near-perpetual state of activity. The lava flows on Io are primarily basaltic, similar to those found on Earth, but the sheer volume and intensity are unparalleled. Some eruptions have been observed to produce lava flows that span hundreds of square kilometers, engulfing entire landscapes in rivers of molten rock. The volcanic plumes, which can reach altitudes of up to 500 kilometers, are composed of a mix of sulfur and sulfur dioxide, creating a toxic, corrosive atmosphere that would be deadly to any life as we know it. The tidal forces at play also cause Io's surface to be in a state of constant flux. Mountains rise and fall, lava lakes ebb and flow, and the very ground shifts beneath the relentless onslaught of volcanic activity. This dynamic environment makes Io a place of extreme danger, where the ground can literally open up beneath your feet. The heat and radiation from the constant eruptions would make survival impossible for any known form of life. Yet, despite the harsh conditions, Io's volcanic activity provides a unique opportunity for scientists to study the processes that shape planetary bodies, offering insights into the early history of Earth and other terrestrial planets. Jupiter's grasp. Beneath the vast, stormy skies of Jupiter, a dance of cosmic proportions unfolds. Io, one of the gas giant's moons, is locked in a gravitational tug-of-war, its very essence shaped by the relentless pull of its parent planet. This ceaseless interaction, known as tidal flexing, is the engine behind Io's fiery temperament. Jupiter's immense gravity distorts Io's shape, squeezing and stretching it like a stress ball. The moon's interior heats up due to this constant deformation, turning it into a volcanic inferno. The scale of this volcanism is staggering, with lava fountains reaching hundreds of kilometers into the sky, painting the landscape with rivers of molten rock. The danger posed by Io's volcanic activity is not just a spectacle, it's a constant, ever-present threat. The moon's surface is a patchwork of fiery vents and vast lava lakes, where temperatures can soar above 1,600 degrees Celsius. Explosive eruptions are common, blasting plumes of sulfur and silica particles high above the surface. These plumes can form rings around Jupiter, creating temporary, ephemeral structures in the planet's vicinity. The sheer power of these eruptions is hard to fathom, with some blasts sending material hurtling into space at speeds of up to 1 kilometer per second. Io's volcanism is not just a surface phenomenon. It's a deep, pervasive force that shapes the moon's very structure. The moon's interior is a churning, molten cauldron, with magma chambers and lava tubes crisscrossing beneath the surface. This subterranean activity is a testament to the moon's volatile nature, a constant reminder of the raw, untamed power that lies beneath. The heat generated by tidal flexing is so intense that it can melt rock, creating vast reservoirs of magma that periodically erupt, reshaping the landscape in dramatic fashion. The danger of Io's volcanic activity extends beyond the moon itself. The constant eruptions create a dynamic and hazardous environment around Jupiter. The ejected material can form a torus of plasma around the planet, influencing its magnetic field and creating a complex, ever-changing electromagnetic environment. This plasma torus is a testament to the interconnectedness of the Jovian system, a reminder that Io's fiery temper has repercussions far beyond its immediate vicinity. The moon's volcanism is a stark reminder of the raw, untamed power that lies beneath the surface of seemingly innocuous celestial bodies. The dance of destruction. Beneath the icy crust of Europa, a world of fire and fury churns. Io, Jupiter's third-largest moon, is a celestial body unlike any other. It's a place where the ground is never still, where the very surface is in a constant state of upheaval. Io is the most volcanically active body in the solar system, a fact that paints a picture of a world in perpetual turmoil. The moon's surface is a patchwork of fiery lava flows, towering volcanic mountains, and vast lava lakes, all testament to the immense geological forces at play. The scale of volcanism on Io is staggering. Volcanoes on Earth can be impressive, but they pale in comparison to the monstrous eruptions that occur on Io. Some of these volcanic eruptions can send plumes of gas and dust hundreds of kilometers into space. The lava flows on Io are not mere trickles. They are vast rivers of molten rock that can reshape the moon's surface in a matter of hours. The heat generated by these eruptions is so intense that it can create vast lakes of liquid lava, some of which are hundreds of square kilometers in size. The danger posed by these eruptions is not just theoretical. It's a constant, ever-present reality for this tortured moon. The dance of destruction on Io is a result of its unique position in the Jovian system. Io is locked in a gravitational tug-of-war between Jupiter and its other moons, a situation that causes immense tidal forces to act upon it. These forces flex and squeeze the moon, generating tremendous heat in its interior. This heat is released through volcanic activity, a process that has been ongoing for billions of years. The result is a world that is in a constant state of flux, where the ground is never still, and the sky is often filled with the glow of erupting volcanoes. It's a place of beauty and terror, a testament to the raw power of nature. The danger posed by Io's volcanic activity is not just a matter of scale, it's also a matter of frequency. On Earth, volcanic eruptions are relatively rare events, even in the most active regions. But on Io, volcanic activity is constant and widespread. The moon's surface is pockmarked with hundreds of active volcanoes, each capable of unleashing devastating eruptions at any time. The lava flows from these eruptions can travel vast distances, covering the moon's surface in a thick layer of molten rock. The plumes of gas and dust that are ejected into space can also pose a threat to any spacecraft that might venture too close. In short, Io is a place of constant danger, a world where the dance of destruction never ends. Io's crumbling crust. Beneath the stark, pockmarked surface of Io, a hellish dance of fire and ice unfolds. This moon of Jupiter is a world in turmoil, its crust a fragile shell barely containing the inferno beneath. Io's volcanism is not a gentle, Earth-like affair, but a relentless, planet-wide conflagration. With over 400 active volcanoes, it is the most volcanically active body in the solar system. The scale of this activity is staggering, with lava fountains reaching hundreds of kilometers into the sky, and lava flows that stretch for hundreds of kilometers, painting the surface in vivid hues of orange, red, and black. The heat driving this volcanism comes from the relentless tug-of-war between Jupiter's immense gravity and the other moons in the system. This constant squeezing and stretching generates tremendous heat, enough to melt rock and create a vast subsurface ocean of magma. The crust, a mere 20 to 30 kilometers thick, is under constant assault. It cracks and fractures, allowing the magma to erupt in spectacular fashion. The surface is a patchwork of volcanic plains, mountains, and lava lakes, a testament to the ceaseless geological activity. The danger posed by Io's volcanism is hard to overstate. The eruptions are not isolated events, but a constant, planet-wide upheaval. The lava flows are not mere trickles, but vast rivers of molten rock, capable of reshaping the landscape in an instant. The fountains of lava are not gentle spouts, but towering columns of fire, dwarfing anything seen on Earth. The surface is a hazardous maze of molten rock and toxic gases, a place where the unwary would be vaporized in an instant. Yet, for all its danger, Io's volcanism is a sight to behold. The eruptions are a dazzling display of nature's power, a symphony of fire and ice. The lava flows create a mosaic of colors, a stark contrast to the blackness of space. The fountains of lava are a mesmerizing spectacle, a dance of fire against the backdrop of the cosmos. Io is a world in turmoil, a place of danger and beauty, a testament to the raw, untamed power of nature. Lava lakes and volcanic plumes. Io, Jupiter's third largest moon, is a celestial body racked by relentless volcanic activity, a fiery inferno in the cold expanse of space. The moon's surface is a chaotic mosaic of lava lakes and towering volcanic plumes, a testament to the immense tidal forces exerted by Jupiter's gravity. These forces generate colossal heat, turning Io into the most volcanically active body in our solar system. The scale of this volcanism is staggering, with lava fountains reaching hundreds of kilometers into the sky, and lakes of molten rock sprawling across the landscape. The lava lakes on Io are vast, molten seas of basaltic lava, their surfaces roiling and bubbling with intense heat. The most famous of these is Loki Patera, a depression filled with lava that spans over 200 kilometers in diameter. This infernal lake periodically brightens and dims, suggesting massive waves or overturns of lava within. The temperatures here can soar above 1 600 degrees Celsius, hot enough to vaporize metals like zinc and lead. The danger posed by these lakes is not to be underestimated. Their sheer size and heat make them a formidable force, capable of reshaping the moon's surface in an instant. Volcanic plumes on Io are another spectacular and perilous feature. These towering columns of gas and dust can reach heights of up to 500 kilometers, dwarfing even the most powerful volcanic eruptions on Earth. The plumes are composed of sulfur and sulfur dioxide, spewed out by the moon's numerous volcanoes. The Pele plume, for instance, is one of the most prominent, creating a vast, red ring of deposits around its source. These plumes not only reshape Io's surface, but also contribute to a thin, dynamic atmosphere. The danger they pose is not just local. The ejected material can travel great distances, coating the moon in a fine, sulfurous dust. The interplay between lava lakes and volcanic plumes creates a dynamic and hazardous environment. The lava lakes provide a constant source of heat and molten material, fueling the volcanic plumes. This cycle of activity is relentless, with new plumes forming and old ones dissipating in a never-ending dance of fire and ice. The scale of this activity is hard to comprehend, with entire regions of the moon being reshaped in a geologically short period. Io is a world in constant flux, a fiery testament to the raw power of volcanic activity. The Great Red Spot's influence. Jupiter's moon Io is a celestial body racked by relentless volcanic activity, a fiery inferno of constant eruption. This intense volcanism is largely driven by the gravitational tug-of-war between Jupiter and its other large moons, which stretches and squeezes Io, generating immense heat. But the Great Red Spot, a colossal storm on Jupiter that has raged for centuries, also plays a subtle yet significant role in Io's volcanic frenzy. The spot's influence is a testament to the interconnectedness of celestial bodies and the far-reaching effects of even distant phenomena. The Great Red Spot, a storm larger than Earth itself, creates waves in Jupiter's atmosphere that ripple outward, influencing the entire Jovian system. These waves, though subtle, can affect Io's orbit, causing slight variations in its distance from Jupiter. These variations, in turn, alter the gravitational forces acting on Io, exacerbating the tidal heating that drives its volcanism. It's a complex interplay, a cosmic dance of forces that culminates in Io's fiery spectacle. The result is a moon that is constantly reshaped by its own volcanic activity, with lakes of molten lava, towering volcanic plumes, and a surface that is continually repaved with fresh, fiery material. Consider Loki Patera, one of Io's most active volcanoes. It's a vast depression filled with molten lava, periodically resurfaced by volcanic upheavals. The lava fountains here can reach heights of up to 15 kilometers, painting the sky with fiery hues. This is just one of the over 400 active volcanoes on Io, each a testament to the moon's tumultuous nature. The energy released by these volcanoes is staggering, with some eruptions releasing as much energy as the entire human population uses in a year. The Great Red Spot, though distant, is a silent partner in this fiery symphony, its influence a subtle yet undeniable force in Io's volcanic drama. The danger posed by Io's volcanism is not just a spectacle for distant observers. It's a harsh reality for any future exploration of the moon. The intense radiation from Jupiter, combined with the constant volcanic activity, makes Io a treacherous environment. Probes would need to be highly shielded and robust to survive the onslaught. Yet, despite the danger, Io offers a unique opportunity to study the extreme conditions of tidal heating and volcanic activity, providing insights into the early Earth and other celestial bodies. The Great Red Spot, with its far-reaching influence, is a reminder of the interconnectedness of our solar system, a cosmic web where even distant phenomena can shape the fate of a moon. A symphony of fire. Beneath the icy crust of Europa, a world of fire and fury rages. Io, Jupiter's third-largest moon, is a celestial body unlike any other. It's a place where the ground is never still, where the very surface is a shifting, molten tapestry of destruction and creation. Io is the most volcanically active body in the solar system, a fact that is as awe-inspiring as it is terrifying. The moon's surface is a patchwork of fiery lava flows, towering volcanic plumes, and vast, steaming lakes of molten rock. This is a world where the temperature can soar to a scorching 600 degrees Celsius, hot enough to melt iron and nickel. The scale of volcanism on Io is staggering, with over 400 active volcanoes dotting its surface. These volcanoes are not the gentle, slumbering giants we find on Earth, but rather, they are violent, explosive beasts that spew forth rivers of fire and towering columns of ash and gas. The volcanic activity on Io is driven by a process known as tidal heating. As Io orbits Jupiter, the planet's immense gravitational pull squeezes and stretches the moon, generating immense amounts of heat. This heat builds up beneath the surface, creating a vast, subterranean ocean of molten rock. When the pressure becomes too great, the magma finds a way to the surface, erupting in spectacular fashion. The largest of these eruptions can send plumes of gas and ash soaring hundreds of kilometers into the sky, creating a dramatic display that can be seen from Earth. The lava flows that result from these eruptions can cover hundreds of square kilometers, reshaping the moon's surface in a matter of hours. The scale of this activity is truly mind-boggling, with some estimates suggesting that Io's volcanoes produce more lava in a single day than all of Earth's volcanoes combined. The danger posed by Io's volcanic activity is not to be underestimated. The moon's surface is a hostile, unforgiving landscape where the ground can give way at any moment, swallowing the unwary in a sea of molten rock. The air is filled with toxic gases, and the temperature is hot enough to melt lead. Even the most hardened of explorers would find it a challenge to survive in such an environment. Yet, despite the danger, Io's volcanic activity is a source of fascination for scientists and space enthusiasts alike. It is a reminder of the raw, untamed power of nature and a testament to the incredible diversity of the solar system. In the words of one scientist, Io is a world on fire, a symphony of destruction and creation that plays out in real time. It is a place that demands our respect, our awe, and our attention. The largest volcanoes in the solar system. Beneath the icy crust of Jupiter's moon Io, a tumultuous dance of tidal forces stirs a magma ocean, fueling the most violent volcanic activity in the solar system. This tiny world, barely larger than Earth's moon, is a fiery inferno, its surface a patchwork of molten lava lakes, towering volcanic plumes, and colossal shield volcanoes. Among these, the largest volcanoes dwarf their terrestrial counterparts, their scale and fury a testament to the raw power of Io's interior. Consider Loki Patera, a vast volcanic depression filled with a churning lake of molten silicate lava. Stretching over 200 kilometers across, it's larger than the island of Hawaii. When it erupts, the heat from the exposed lava can cause massive plumes of gas and dust to billow up to 300 kilometers into the thin Ionian atmosphere. The energy released is staggering, enough to light up the moon's night side and leave a visible scar on the solar system's largest planet, Jupiter. Then there's Surt, a monstrous shield volcano that rises over 3 kilometers above the surrounding plains. Its gentle slopes belie the sheer volume of lava it has erupted over time. Shield volcanoes like Surt are built from the slow accumulation of low-viscosity lava, creating a broad, gently sloping dome. On Earth, the largest shield volcanoes, like Mauna Loa in Hawaii, are impressive, but Surt makes them look puny. Its base sprawls across hundreds of kilometers, making it one of the largest volcanic structures in the solar system. The danger posed by these volcanic behemoths is not to be underestimated. Eruptions on Io are not mere spectacle. They are cataclysmic events that can reshape the moon's surface in an instant. The lava flows are incredibly hot, reaching temperatures of over 700 degrees Celsius. The volcanic plumes, laden with sulfur and other compounds, can reach escape velocity, contributing to Io's thin atmosphere and even influencing Jupiter's magnetosphere. The sheer scale of volcanism on Io is a stark reminder of the violent forces at work in our solar system. Pele, the monster volcano. Beneath the icy crust of Jupiter's moon Io, a tumultuous dance of tidal forces churns, driving the most relentless volcanic activity in our solar system. Pele, a colossal volcano, stands as a testament to this fury. It's not just any volcano. It's a monster, a fiery behemoth that spews lava fountains reaching hundreds of kilometers into the thin, sulfur dioxide-rich atmosphere. The scale is hard to fathom. On Earth, we marvel at eruptions that disrupt air traffic or bury cities. But Pele's lava flows can stretch for hundreds of kilometers, painting the surface with fresh, molten rock. The heat is so intense that it can create glowing lakes of lava, their surfaces roiling with waves of molten rock. The danger posed by Pele is not just in its size, but in its unpredictability. Unlike Earth's volcanoes, which often give some warning before erupting, Io's volcanic activity is driven by the relentless tug of Jupiter's gravity. This makes Pele's eruptions a constant threat. The lava it produces is incredibly hot, with temperatures soaring above 700 degrees Celsius. This is hot enough to vaporize rocks and create vast plumes of gas and ash that can escape Io's gravity and contribute to Jupiter's magnetosphere. The sheer power of these eruptions can reshape the moon's surface in a matter of hours, burying old features and creating new ones. Pele's activity is not just a spectacle, it's a reminder of the raw power of nature. The volcano's name, after the Hawaiian goddess of fire and volcanoes, is fitting. Like its namesake, Pele is a force to be reckoned with. Its eruptions can send shockwaves through Io's thin atmosphere, creating massive, umbrella-shaped clouds of gas and dust. These plumes can reach altitudes of up to 500 kilometers, making them visible from space. The lava flows from Pele can cover areas the size of small countries. They're glowing rivers of molten rock, carving new paths across the moon's surface. The danger is ever-present, a constant reminder of the volatile world that is Io. Despite the danger, studying Pele and other volcanoes on Io provides invaluable insights into the workings of our solar system. The data collected from these distant eruptions helps scientists understand the processes that shape planetary bodies. It's a harsh, unforgiving environment, but one that offers a unique window into the geophysical forces at play. Pele's monstrous eruptions are a stark reminder of the power of nature, a force that shapes worlds and defies comprehension. Loki, the shape-shifting giant. Beneath the icy crust of Jupiter's moon Io, a titanic force stirs. Loki, the most powerful volcano on Io, is a relentless testament to the moon's status as the most volcanically active body in our solar system. This colossal feature is not a single, stationary volcano, but a vast, ever-shifting lava lake, a churning maelstrom of molten rock that sprawls across an area larger than New York City. Loki's lava lake is a geologist's nightmare and a dream rolled into one, a place where the ground is perpetually in flux, reshaping itself in a violent, fiery dance. The scale of Loki's volcanism is staggering. The lava lake is fed by a vast reservoir of magma beneath Io's surface, a bubbling cauldron of molten rock that periodically overflows, sending rivers of fire cascading across the moon's surface. These eruptions can cover areas of up to 500 square kilometers, an area larger than the state of New Jersey. The lava flows are not gentle, meandering rivers, but torrents of molten rock that can reach temperatures of up to 700 degrees Celsius, hot enough to vaporize rock and reduce it to ash. The heat and energy released during these eruptions are so immense that they can be detected by telescopes on Earth, a faint glow in the darkness of space. Loki's volcanism is not just a spectacle, but a constant, ever-present danger. The moon's surface is a patchwork of lava flows, some fresh and steaming, others ancient and cold. The ground is unstable, prone to collapse and subsidence as the lava beneath it shifts and moves. The atmosphere is a toxic brew of sulfur dioxide and other volcanic gases, a choking, corrosive mist that would be lethal to any life as we know it. Yet, despite the danger, Loki's volcanism is a vital part of Io's story, a testament to the raw, untamed power of the solar system. The shape-shifting nature of Loki is a constant challenge for scientists. The lava lake is not static, but a dynamic, ever-changing feature. It can change shape and size over the course of hours or days, a shifting, restless beast that defies easy study. The lava flows can carve new channels and paths, altering the landscape in dramatic ways. The eruptions can be unpredictable, sudden, and violent, making it difficult for scientists to study the volcano in detail. Yet, despite these challenges, Loki remains a fascinating subject of study, a window into the fiery heart of Io. Mama, the mother of all eruptions. Beneath the icy crust of Jupiter's moon Io, a tumultuous dance of fire and rock unfolds. This celestial body, slightly larger than Earth's moon, is a volcanic powerhouse, boasting over 400 active volcanoes. Among these, one eruption stands out, a titanic event dubbed Mama, the mother of all eruptions. This colossal outburst, observed by NASA's New Horizons spacecraft, spewed a plume of gas and dust that soared 330 miles above Io's surface, a height that dwarfs even the most catastrophic volcanic events on Earth. The sheer scale of this eruption is a stark reminder of the raw, unbridled power that lurks beneath Io's surface. The energy unleashed during the Mama eruption is difficult to comprehend. It's estimated that the event released around 20 terawatts of energy, equivalent to the power output of about 20 nuclear reactors. This staggering figure is a testament to the intense geological activity that drives Io's volcanism. The moon's proximity to Jupiter subjects it to immense tidal forces, which knead and heat its interior, creating a molten hellscape beneath its surface. The result is a landscape pockmarked with volcanoes, lava lakes, and towering mountains. Io's volcanism is not merely a spectacle, it's a constant, ever-present danger. The moon's surface is a mosaic of fresh lava flows, some stretching for hundreds of miles. These rivers of fire can reach temperatures of over 20 degrees Fahrenheit, hot enough to melt steel. The constant bombardment of sulfur and other volcanic gases has created a toxic atmosphere, a choking shroud that would be lethal to any life as we know it. Yet, despite the harsh conditions, Io's volcanoes continue to erupt, a relentless display of nature's fury. The Mama eruption is a stark reminder of the power of volcanic activity. It's a spectacle that dwarfs anything seen on Earth, a testament to the raw, unbridled energy that lies beneath the surface of this tiny moon. Io's volcanoes are a constant, ever-present danger, a reminder that even in the cold, dark reaches of space, the fires of creation burn bright. The Mama eruption is a stark reminder of the power of volcanic activity. It's a spectacle that dwarfs anything seen on Earth, a testament to the raw, unbridled energy that lies beneath the surface of this tiny moon. Io's volcanoes are a constant, ever-present danger, a reminder that even in the cold, dark reaches of space, the fires of creation burn bright. The constant rain of fire. Beneath the icy crust of Europa, a world of fire and fury rages. Io, Jupiter's third-largest moon, is a celestial body unlike any other. It's a place where the ground is never still, where the very surface is in a constant state of upheaval. This is a world where volcanoes erupt with such frequency and violence that it's been dubbed the most volcanically active body in our solar system. The scale of this activity is staggering, with over 400 active volcanoes dotting its surface. These aren't the gentle, cone-shaped mountains we're familiar with on Earth. Instead, they are vast, sprawling structures, some stretching hundreds of kilometers across. The lava that flows from these volcanoes is not the slow-moving, viscous type we see on Earth. Instead, it's a fast-moving, low-viscosity lava that can travel great distances, covering the surface in a molten blanket. The heat and pressure that drive this relentless volcanic activity are immense. Io's interior is kept in a state of perpetual turmoil by the gravitational tug-of-war between Jupiter and its other moons. This constant squeezing and stretching generates tremendous heat, which in turn melts the rock beneath the surface. The result is a vast, underground ocean of magma, a seething, churning sea of molten rock. When this magma finds a weak spot in the crust, it erupts in a spectacular display of fire and fury. The eruptions can be so powerful that they send plumes of gas and dust hundreds of kilometers into the sky. These plumes are so large that they can be seen from Earth with a powerful telescope. The constant rain of fire that falls on Io is a testament to the sheer scale of its volcanic activity. The surface is a patchwork of lava flows, some fresh and glowing red-hot. others older and cooled to a dull gray. The lava flows can be so extensive that they can bury entire mountains and craters, reshaping the surface in a matter of years. The heat from the eruptions is so intense that it can vaporize the sulfur and other volatile compounds on the surface, creating a thin, temporary atmosphere. This atmosphere is constantly being replenished by the eruptions, only to be lost to space when Io moves out of Jupiter's shadow. The danger posed by this constant rain of fire is immense. The surface temperature can reach over 1,600 degrees Celsius, hot enough to melt steel. The radiation levels are also extremely high, making Io a place that would be deadly to any form of life as we know it. Yet, despite the danger and the chaos, there is a certain beauty to Io's constant rain of fire. The eruptions create a dynamic, ever-changing landscape that is a stark contrast to the static, frozen worlds that make up much of the outer solar system. The plumes of gas and dust create a spectacular display that is visible from great distances. The lava flows create a mosaic of colors, from the bright red of fresh lava to the deep black of cooled rock. Io is a world of fire and fury, a place where the very ground is in a state of constant upheaval. It is a place of danger and chaos, but also a place of breathtaking beauty and awe-inspiring power. Io's thin, toxic atmosphere. Io, Jupiter's third-largest moon, is a world of fire and chaos, a place where the very ground is a battleground of titanic forces. Beneath its colorful, cracked surface, the moon is in a constant state of upheaval, driven by the relentless gravitational tug-of-war with Jupiter. This makes Io the most volcanically active body in the solar system, a place where lava fountains erupt hundreds of miles into the sky, painting the landscape with rivers of molten rock. The scale of this volcanism is staggering, with over 400 active volcanoes dotting the surface, some of which are capable of producing eruptions that dwarf anything seen on Earth. The intense volcanic activity has a profound impact on Io's atmosphere, creating a thin, toxic shroud that clings to the moon's surface. This atmosphere is a dynamic and ever-changing environment, composed primarily of sulfur dioxide, SO2, along with traces of sulfur monoxide, SO, sodium chloride, NaCl, and atomic sulfur and oxygen. The sulfur dioxide comes from the volcanic eruptions, which spew vast quantities of the gas into the air. In fact, the volcanoes on Io are so powerful that they can temporarily inflate the moon's atmosphere, creating a temporary exosphere that extends for hundreds of miles. The atmosphere of Io is not a place for the faint-hearted. It is a harsh, unforgiving environment, filled with toxic gases and scorching temperatures. The sulfur dioxide, for instance, can react with other chemicals in the atmosphere to form sulfuric acid, a highly corrosive substance that can eat through metal. The temperatures on Io are also extreme, with the surface temperature ranging from around -200 degrees Fahrenheit -130 degrees Celsius in the polar regions to nearly 300 degrees Fahrenheit 150 degrees Celsius near the volcanic vents. This makes Io a place of stark contrasts, where the cold of space meets the fiery heat of the volcanoes. Despite its harsh conditions, Io's atmosphere is a fascinating subject of study for scientists. It provides a unique opportunity to understand the processes that shape the atmospheres of other planetary bodies. The constant volcanic activity also makes Io a natural laboratory for studying the interactions between a planet's interior and its atmosphere. By studying Io, scientists hope to gain insights into the early history of the Earth and other terrestrial planets, as well as the processes that shape the atmospheres of exoplanets. In this sense, Io's thin, toxic atmosphere is not just a dangerous place, but also a window into the broader universe. The dance of sulfur and silicate. Beneath the icy crust of Jupiter's moon Io, a tumultuous dance unfolds, one that paints the surface with rivers of fire and blankets the sky with sulfurous plumes. This is a world where volcanism isn't just a force of nature. It's the dominant character in a dramatic, ongoing performance. Io's volcanism is staggering in scale, with over 400 active volcanoes dotting its surface. These aren't the gentle, shield volcanoes of Hawaii, but towering, explosive beasts that spew lava fountains hundreds of kilometers high. The largest eruptions can leave scars visible from Earth, vast fields of frozen lava that stretch for hundreds of square kilometers. The dance partners in this fiery ballet are sulfur and silicate. Sulfur, a volatile element, is abundant on Io, and it's responsible for the moon's vibrant, multicolored surface. When Io's volcanoes erupt, they spew out a mix of sulfur and silicate magma. The sulfur, with its low boiling point, vaporizes quickly, creating vast clouds of sulfur dioxide that can envelop the entire moon. The silicate magma, meanwhile, flows like rivers of fire, carving out channels and creating vast lava lakes. The interaction between these two elements creates a dynamic, ever-changing landscape that's unlike anywhere else in the solar system. The danger posed by Io's volcanism is hard to overstate. The eruptions are not only explosive but also frequent. Some volcanoes erupt continuously, while others go through cycles of activity and dormancy. The largest eruptions can release as much energy as the most powerful nuclear weapons, creating shock waves that ripple through the moon's thin atmosphere. The sulfur dioxide clouds can block out the sun, causing rapid temperature drops. Meanwhile, the silicate lava flows can reach temperatures of over 700 degrees Celsius, hot enough to melt most metals. Io is a world of extremes, a place where the dance of sulfur and silicate is a constant, dangerous spectacle. A world in perpetual motion. Beneath the icy crust of Europa, a world of perpetual motion churns with a fury that defies imagination. Io, Jupiter's third-largest moon, is a celestial body racked by relentless volcanic activity, a fiery inferno that makes Earth's most explosive eruptions seem like mere embers. This tiny moon, barely larger than our own, is a testament to the raw, unbridled power of the cosmos. Its surface is a mosaic of sulfur lakes, towering volcanic plumes, and rivers of molten lava that carve deep, black channels into the landscape. The scale of volcanism on Io is staggering, with eruptions that can spew material hundreds of kilometers into the sky, creating vast, billowing clouds that encircle the moon. The driving force behind Io's perpetual motion is the relentless gravitational tug-of-war between Jupiter and its other large moons, Europa and Ganymede. This constant gravitational squeezing and stretching generates immense tidal forces within Io, heating its interior to temperatures hot enough to melt rock. The result is a world where volcanoes erupt continuously, their fiery breath painting the landscape in vivid hues of red, orange, and yellow. Some of these volcanoes are so powerful that they can reshape the moon's surface in a matter of hours, creating new mountains and valleys in a geological blink of an eye. The heat and pressure within Io are so intense that they create vast underground magma chambers, which periodically burst through the surface in spectacular eruptions. The danger posed by Io's volcanic activity is not just a matter of scale, but also of frequency. Unlike Earth, where volcanic eruptions are sporadic and often predictable, Io's volcanoes erupt constantly, with some entering into near-permanent states of activity. This relentless volcanism creates a hostile environment where the surface is constantly bombarded by molten lava, toxic gases, and scorching temperatures. The moon's thin atmosphere is a toxic brew of sulfur dioxide and other volcanic gases, making it inhospitable to life as we know it. Despite the danger, Io's volcanic activity provides scientists with a unique opportunity to study the processes that shape planetary bodies, offering insights into the early history of our own planet and the potential for volcanic activity on other worlds. Io's volcanic plumes are among the most dramatic features of this fiery moon. These towering columns of gas and ash can reach heights of up to 500 kilometers, dwarfing even the most powerful eruptions on Earth. The plumes are composed of a mix of sulfur, sulfur dioxide, and other volcanic gases, which are ejected at speeds of up to 1 kilometer per second. As the plumes rise, they spread out into vast, umbrella-shaped clouds that can cover entire regions of the moon. The material ejected by these plumes eventually falls back to the surface, creating a fine, powdery layer of sulfur and other volcanic debris. This process is so intense that it can completely resurface Io in a matter of centuries, making it one of the most geologically active bodies in the solar system. The future of Io's inferno. Io, Jupiter's third-largest moon, is a world of ceaseless turmoil, a place where the very ground is a shifting, molten tapestry. This tiny moon, slightly larger than Earth's moon, is the most volcanically active body in our solar system. Its surface is a hellscape of erupting volcanoes, lava lakes, and towering plumes of sulfur and sulfur dioxide. The scale of volcanism on Io is staggering, with over 400 active volcanoes dotting its surface. These volcanoes are not the gentle, shield-like structures seen on Earth, but rather towering, explosive behemoths that spew lava fountains hundreds of kilometers high. The lava on Io is incredibly hot, reaching temperatures of around 600 degrees Celsius, 900 degrees Fahrenheit, hot enough to melt iron and nickel. The moon's surface is a patchwork of yellow, orange, and red hues, a stark contrast to the cold, dark void of space. The future of Io's inferno is a tale of relentless geological activity, driven by the immense tidal forces exerted by Jupiter and its other moons. These forces stretch and squeeze Io, generating tremendous heat through friction. This process, known as tidal heating, is the engine that drives Io's volcanic activity. The moon's interior is a churning maelstrom of molten rock, with vast magma chambers feeding the surface volcanoes. The lava that erupts from these volcanoes is primarily basaltic, similar to the lava found on Earth, but with a higher concentration of sulfur and other volatile compounds. These compounds contribute to the vivid colors seen on Io's surface and create the towering plumes that can reach heights of up to 500 kilometers. The danger posed by Io's volcanic activity is not just a local concern. The moon's eruptions can have far-reaching effects, influencing the entire Jovian system. The plumes of sulfur and sulfur dioxide that erupt from Io's volcanoes can spread outwards, forming a vast torus of material around Jupiter. This torus, known as the Io plasma torus, is a region of intense radiation that can pose a hazard to spacecraft and future human explorers. The constant bombardment of Io's surface by Jupiter's magnetic field also contributes to the moon's extreme environment, creating a dynamic and ever-changing landscape. The future of Io's inferno is one of ongoing geological activity, with no signs of abating. The moon's unique position within the Jovian system ensures that it will continue to be a world of fire and fury. Scientists believe that Io's volcanic activity may even increase in the future as the tidal forces exerted by Jupiter and its other moons continue to shape the moon's interior. The study of Io provides valuable insights into the processes that shape our own planet and the other rocky worlds in our solar system. It is a testament to the power of geological forces and a reminder of the dynamic and ever-changing nature of our universe. Humanity's fascination with fire. Io, Jupiter's third-largest moon, is a celestial body that burns with an intensity rarely seen elsewhere in our solar system. Its surface is a fiery tapestry, a relentless dance of destruction and creation. This tiny world, slightly larger than Earth's moon, is the most volcanically active body in the solar system. It boasts over 400 active volcanoes, spewing out sulfur and silicon dioxide that paint its surface in hues of red, yellow, and black. The scale of volcanism on Io is staggering. Some of its volcanoes can eject material up to 300 miles, 500 kilometers, into space. The largest eruptions can leave scars on the surface that are hundreds of miles across. It's a world where the ground is never still, where the very surface is in a constant state of flux. The power of Io's volcanism is fueled by the relentless tug of Jupiter's gravity. As Io orbits the gas giant, it is stretched and squeezed, a process known as tidal flexing. This constant kneading generates immense heat, enough to melt rock and drive the moon's volcanic activity. The result is a surface that is a patchwork of lava flows, volcanic plumes, and mountains. Some of these mountains are taller than Mount Everest, their peaks shrouded in the perpetual twilight of Io's thin atmosphere. The lava flows on Io are not the gentle, slow-moving rivers of molten rock seen on Earth. Instead, they are fast-moving, incandescent rivers of fire that can carve new landscapes in a matter of hours. Humanity's fascination with fire is deeply rooted in our psyche. It is a primal force, both creative and destructive. On Earth, we have learned to harness fire, to use it to shape our world and advance our civilization. But on Io, fire is a raw, untamed force. It is a constant reminder of the power of nature, of the relentless drive of the universe to create and destroy. The images of Io's volcanic activity, captured by spacecraft like Voyager and Galileo, are a stark reminder of the dangers that lurk in the cosmos. They are a testament to the power of fire, a force that can shape worlds and reshape our understanding of the universe. The study of Io's volcanism is not just about understanding a distant moon. It is about understanding the processes that shape our own planet. Volcanism on Earth has played a crucial role in shaping our climate, our oceans, and even the evolution of life. By studying Io, we can gain insights into the processes that drive volcanism on Earth and elsewhere in the solar system. It is a reminder that, despite our advancements, we are still at the mercy of the forces of nature. Io, with its fiery surface and relentless volcanism, is a stark reminder of the power of fire and the dangers that lurk in the cosmos. The quest to understand Io. Io, Jupiter's third largest moon, is a world of fire and fury, a place where the very ground is a shifting, molten landscape. It's the most volcanically active body in our solar system, with over 400 active volcanoes, dwarfing even Earth's most tumultuous regions. The scale of volcanism on Io is staggering, with lava fountains reaching hundreds of kilometers into the sky, and lava flows that stretch for hundreds of kilometers, painting the surface with rivers of fire. The heat and energy released are so immense that they create vast, glowing lakes of molten rock, their surfaces roiling and bubbling like a cauldron from some ancient myth. Scientists are drawn to Io like moths to a flame, eager to understand the forces that drive this infernal world. The quest to understand Io is a challenge, a puzzle wrapped in a riddle, cloaked in a shroud of fire. The moon's extreme volcanism is primarily driven by tidal heating, a result of the gravitational tug-of-war between Jupiter and its other large moons, Europa and Ganymede. This constant flexing and squeezing generates immense heat, enough to melt Io's rocky interior and fuel its relentless volcanic activity. Yet, the exact mechanisms and the full extent of this process remain shrouded in mystery, waiting to be unraveled. The danger and unpredictability of Io's surface make it a treacherous place to study. The constant eruptions and lava flows mean that the surface is in a state of perpetual flux, with new features forming and old ones disappearing in the blink of an eye. The radiation environment is also hazardous, with Io bathed in intense radiation belts from Jupiter. Despite these challenges, scientists are undeterred, using advanced spacecraft and instruments to peer through the fiery veil and uncover Io's secrets. They study the composition of Io's lava flows, the dynamics of its eruptions, and the interactions between its volcanic activity and its tenuous atmosphere. One of the most intriguing aspects of Io's volcanism is its diversity. Unlike Earth, where most volcanoes are either basaltic or rhyolitic, Io's volcanoes display a wide range of compositions and eruption styles. Some eruptions are effusive, with lava flowing gently and steadily, while others are explosive, with violent blasts of molten rock and gas. This diversity provides a unique opportunity to study volcanic processes under extreme conditions, offering insights that could revolutionize our understanding of volcanism not just on Io, but throughout the solar system and beyond. The quest to understand Io is not just a journey into the heart of a fiery world, but a voyage of discovery that could illuminate the very nature of planetary evolution. As we wrap up our journey to Io, the fiery heart of our solar system, let's take a moment to soak in the sheer scale of what we've witnessed. This moon, barely larger than our own, is a volcanic powerhouse, spewing lava fountains that dwarf anything we've ever seen on Earth. The surface is a dynamic, ever-changing landscape of molten rivers and towering volcanic plumes, a testament to the relentless tug-of-war between Jupiter's immense gravity and Io's fiery interior. It's a place where the ground is literally torn apart, where lakes of lava stretch for hundreds of kilometers, and where the sky is filled with the glow of constant eruptions. Io is a world of fire and fury, a place where the very forces that shape planets are on full, spectacular display. As we leave Io behind, we can't help but feel a sense of awe and perhaps a touch of trepidation. This is a place that reminds us of the raw, untamed power of nature, a place where the boundaries between beauty and danger blur into something truly extraordinary. It's a world that challenges our understanding of what's possible, a world that pushes the limits of our imagination. But our exploration doesn't end here. The solar system is vast and full of wonders waiting to be discovered. So, stay tuned, keep exploring, and join us as we continue to unravel the mysteries of our cosmic neighborhood. Who knows what fiery surprises await us next? Until then, keep your eyes on the skies and your spirit of discovery burning bright.